Welcome to this explainer. Today, we're diving deep into the geography of Rajasthan. Now, when most people think of Rajasthan, they picture harsh, unforgiving deserts. And while that's absolutely true, it's also a place that holds the key to India's renewable energy future. We're going to peel back the layers of India's largest state, looking at its physical landscapes, its economy, and its people. It is a wildly fascinating story about how ancient geology and extreme climates have literally shaped human resilience and fueled modern industrial growth. We'll be using some highly detailed academic source material to guide us, but don't worry, we're going to break it all down step by step so it makes perfect sense.
Okay, to truly understand Rajasthan, you first have to wrap your head around its massive scale. We're talking 342,239 square kilometers. That means this one single state accounts for over 10% of India's entire landmass. To put that into perspective, it's actually slightly larger than the entire country of Germany. Because it's so vast, sitting right there in the northwestern part of the subcontinent, you get these crazy local variations, like a full 36-minute difference in solar time just going from its eastern border to its western edge. Plus, it shares a highly strategic 1,070-kilometer international border with Pakistan, known as the Radcliffe Line, while also bumping up against 5 different Indian states.
So, here is how we're going to tackle this dense academic material today. First, physical landscapes and climate. Then, water, soil, and agriculture. Third, resources and industrial growth. Fourth, demographics and tribal heritage. And finally, infrastructure and development.
Let's kick things off with Section 1, Physical Landscapes and Climate. Honestly, the physical structure of the land dictates almost everything else about how life operates here.
Geographically, the state is carved up into 4 main regions. First up is the vast western sandy plain, basically the Thar Desert, which dominates over 61% of the entire state. We're talking endless shifting sand dunes and extreme aridity. Then, slicing right through the middle like a giant spine, is the Aravalli Range. These mountains date all the way back to the Precambrian era, making them some of the absolute oldest relict fold mountains on Earth. Head east of the mountains and you hit the Eastern Plains, covering about 23% of the state. This area is highly fertile thanks to rich river deposits. Finally, tucked down in the southeast, you have the Hadoti Plateau. This is a rugged landscape formed by ancient volcanic lava flows, something geologists call the Deccan Trap.
Because the physical terrain is so varied, the climate is a land of total extremes. If you look at the Köppen's climate classification, the contrast is mind-blowing. Out in the extreme west, places like Jaisalmer and Bikaner are in a hyper-arid desert zone getting less than 20 centimeters of rain a year. But travel down southeast to Banswara or Dungapur, and suddenly you're in a tropical humid zone where rainfall tops 80 centimeters. Now, 90% of that rain comes from the southwest monsoon, but there's also a really crucial winter rain called Mawats. It's driven by Mediterranean disturbances, and without it, winter crops like wheat would absolutely fail.
Moving right along to Section 2, Water, Soil, and Agriculture. When you're dealing with such crazy climatic extremes, just finding water and keeping the soil healthy becomes an incredible story of human resilience.
Get this stat. Rajasthan possesses just 1.16% of India's total surface water. For the country's largest state, that is exceptionally low. And the water it does have, it behaves really strangely. A massive 60% of the state's drainage is entirely inland. That means seasonal rivers, like the Ghaggar, literally flow for a bit and then just vanish, sinking directly into the desert sands before they ever reach an ocean. The rest of the water is split. About 23% flows towards the Bay of Bengal, thanks to the perennial Chambal River and the local Banas River. The remaining 17% heads toward the Arabian Sea. That includes the Luni River, which is wild because its freshwaters actually turn highly saline as they drag through the desert salt.
So, how do they survive with so little surface water? Well, outside of relying heavily on groundwater, they've pulled off some colossal engineering feats. The Indira Gandhi Canal project is the ultimate example of human ingenuity here. It pulls water from the rivers up in Punjab and runs for 649 kilometers. It is the literal lifeline of the Thar Desert, irrigating over 16 lakh hectares. That's roughly 3.9 million acres. It's turned endless stretches of barren sand into green farmland. On top of that, you have massive joint ventures like the Chambal Valley Project and the Mahi Bajaj Sagar Project, which not only provide essential irrigation, but also generate much-needed hydroelectric power.
Thanks to that massive irrigation push, Rajasthan has built an incredibly robust agricultural backbone. They've perfectly adapted to their environment. During the Kharif, or monsoon season, Rajasthan leads the entire nation in producing bajra, which is pearl millet, a hardy, drought-resistant crop that thrives in sandy western soils. But then, in the winter, or Rabi season, the state uses its fertile eastern plains to produce over 40% of India's entire mustard crop. It's a brilliant example of matching crop selection to completely unique soil and climate conditions.
All right, Section 3, Resources and Industrial Growth. Layering on top of the physical geography and farming is the immense wealth hidden just beneath the soil.
Because of those ancient Precambrian geological formations we talked about earlier, Rajasthan is literally known as a museum of minerals. The state produces a staggering 81 different minerals. In fact, it holds a 100% national monopoly on some highly critical resources. We're talking lead-zinc, which is essential for batteries, jasper, a gorgeous red gemstone, and wollastonite, a heat-resistant mineral used in ceramics and car brakes. And we can't forget its world-renowned dimension stones, the pristine white marble used to build the Taj Mahal. Yeah, that was quarried right here in Makrana, over in the Nagar district.
This geological treasure trove is exactly what's fueling rapid industrialization. Take that harsh desert sun. Instead of just enduring it, they've turned it into a massive asset. Rajasthan is now first in India for installed solar potential, boasting the sprawling Badla Solar Park, which generates a massive 2,245 megawatts. Beneath the desert sands in Barmer is the Mangala oil field, which is the largest onshore oil discovery in the whole country. Those mineral monopolies? They feed heavy industries like Asia's largest zinc and lead melting facility at Chandriya. And it's not all just heavy metals. Historically, places like Bhilwara have grown so much, they are literally known as the textile city of India for their cotton processing. Okay, let's pivot to Section 4, Demographics and Tribal Heritage. Let's introduce the 68.54 million people who actually live in this challenging environment. Even with all that rapid industrialization and solar energy booming, the occupational data shows us that the core of the state remains very traditional. A dominant 62% of the workforce is still deeply tied to the primary sector. That means they make their living working directly with the land, through agriculture, mining, and livestock. Speaking of which, Rajasthan ranks second in India overall for livestock, and holds the absolute #1 position for camels and goats. Which makes total sense, right? Those animals are perfectly suited for a pastoral lifestyle in an arid region. But because the physical geography is so drastically varied, the population distribution is incredibly uneven. Geography dictates where you live. For example, look at Jaipur. It's a bustling, highly fertile urban heartland packed with 595 persons per square kilometer. Contrast that with the vast, hyper-arid desert expanse of Jaisalmer, which supports a mere 17 persons per square kilometer. Literally, where the water and the fertile plains are, people gather. Where the desert rains, the population thins out dramatically. Adding an incredible layer of cultural richness to these demographics are the indigenous tribes, who make up over 13% of the state's population. They're mostly concentrated in the Aravalli Mountains and the southern plains. The Meena tribe is the largest, mostly in the east, and they boast the highest literacy and socioeconomic integration. Then you have the Bhils, the ancient inhabitants of the southern Aravallis, who are historically famous for their archery skills. The Gaurasya tribe is known for highly unique marriage customs, including long-term live-in relationships before any formal marriage takes place. And then there are the Sahriya in the Baran district. The government actually identifies them as a particularly vulnerable tribal group, meaning they require special protection to maintain their traditional hunter-gatherer lifestyle deep in the forests.
However, we've got to talk about a major developmental hurdle highlighted by the demographic data. The overall literacy rate in the state sits at around 66%, but what is deeply concerning is the glaring gender gap. While male literacy approaches 80%, female literacy is struggling at just 52.12%, and it's even lower when you look at rural areas specifically. Bridging this gap is absolutely crucial. It's not just a social goal, it's one of the state's most pressing necessities for future growth. Which brings us to our final part, Section 5, Infrastructure and Development. Let's look at how all these layers, the geography, the resources, and the people, intersect to shape the future.
When you break the state down by region, you can brilliantly see cause and effect in action. The physical environment directly dictates the economic reality. In the harsh Marustali desert out west, they harness the sun and wind for renewable energy, while pastoralism dominates the farms. In the Aravallis, the ancient rocks provide metallic minerals and fuel ecotourism. The fertile eastern plain naturally supports intensive agriculture and massive textile manufacturing. And down in the Hadatu Plateau, the black soils and heavy rains are perfect for growing cash crops like soybean, alongside thermal power generation. Geography truly is destiny here.
But that destiny is undergoing a rapid, modern transformation. Massive infrastructure projects like the Delhi-Mumbai Industrial Corridor, which passes right through the state, are paving the way for massive economic change. Because of this, Rajasthan is steadily pushing up its rank in the medium human development category. We're seeing aggressive state healthcare schemes successfully driving down maternal and infant mortality rates. There's a massive shift happening right now from traditional rain-fed subsistence farming to mechanized, irrigated agriculture. And perhaps most importantly, targeted state programs are actively working to break down those sociocultural barriers to improve female education and boost local entrepreneurship. As we wrap up this explainer, I want to leave you with a provocative thought based on everything we've uncovered today. We have seen how Rajasthan's barren deserts secretly hold oceans of oil and boundless solar potential, and how its ancient, weathered mountains hold the critical minerals of tomorrow. So, how will a land built on such extreme climatic hardships continue to turn its harshest elements into its absolute greatest strengths for the future? It's a question of resilience and innovation that will define Rajasthan for decades to come. Thanks for joining me on this explainer, and keep questioning the world around you.
Okay, let's start with a massive number. 10.41%. So, what exactly does that represent? Well, it's Rajasthan's share of India's total landmass. To put that into perspective, by sheer geographical area alone, it is literally the undisputed largest state in the entire country.
But here's the dramatic catch. Despite its immense, sprawling size, this massive state holds a mere 1.16% of India's surface water, and just about 1.72% of its groundwater, right? That staggering mismatch between all that land and so little water, it basically defines absolutely everything about life in this region.
Welcome to this explainer. Today, we are going to unpack the fascinating geography of Rajasthan. We're going to explore how its extreme topography, its totally unique climate patterns, and frankly, its chronic water scarcity have shaped this surprisingly resilient economy and uncovered a literal treasure trove of natural resources. So, we've structured this journey into 5 clear sections: Land of Extremes, the Climate and Water Paradox, Surviving the Grit, the Museum of Minerals, and finally, Fruits of Labor. This setup is going to show us exactly how the state's ancient bedrock dictates its weather, how local communities adapt, and how immense wealth is actually generated from such a tough, harsh landscape.
All right, let's just jump right into our first section and look at the physical foundations of the state, the Land of Extremes.
To really understand this, let's look at one of the first major questions from the source material. How exactly do we explain the physical divisions of Rajasthan? Well, the answer breaks the state down into 4 very distinct divisions based on its relief and structure. The absolute most dominant one is the Western Sandy Plain. You probably know it as the Thar Desert, which covers a whopping 61% of the total area. That's more than half the state.
It's a land of incredibly stark physical contrasts. On one side, you've got the Maraslatali. This is the hyper-arid core of the desert, getting less than 25 centimeters of rainfall a year, totally defined by shifting sand dunes. But acting almost like a massive fortress wall against this desert is the Aravalli Range. Formed way back in the Precambrian era, the Aravallis are actually one of the world's oldest fold mountain systems. They stretch for nearly 700 kilometers and serve as this absolutely crucial climatic barrier. They literally physically stop the desert sands from just expanding right into eastern Rajasthan and the rest of India.
Okay, moving on to Section 2. Let's see how this physical layout directly impacts the region's climate and its whole water paradox.
Which begs a really fascinating question. How exactly do you drain a desert? Like, how does water flow in a land completely defined by aridity and split right down the middle by these massive mountain divides? Well, if we look at scientific classifications, specifically by Köppen and Thornthwaite, they reveal that Rajasthan isn't just, one big dry sandbox. There are intense variations. You've got severe moisture deficits in the hyper-arid western zones, which is that classic tropical desert climate. But as you move southeast, the climate transitions all the way to subtropical, very humid zones. Take elevated pockets like Mount Abu, for instance. It can actually receive well over 150 centimeters of rainfall. Pretty wild, right? So because that Aravalli Range acts as the main watershed line, it essentially splits the state's river flow into 3 totally distinct drainage systems. About 60% of the water drains eastward into the Bay of Bengal through rivers like the Chambal. Then another 17% flows out west into the Arabian Sea through rivers like the Luni. But here is the most incredible part, in my opinion. Roughly 23% of the region operates on an inland drainage network, meaning ancient seasonal rivers like the Gagar, They don't flow into any ocean. No, they just flow right into the desert and eventually disappear into the sand. It's like magic. And that brings us to Section 3, surviving the grit. With rivers literally evaporating into the sand and rainfall varying so wildly, how does life actually endure here?
The really crucial thing here is understanding the dual, chronic threats this whole region faces: drought and desertification. The source material explains this in detail, pointing out that this land degradation is driven by a mix of natural and man-made causes. Naturally speaking, erratic monsoons and super high temperatures cause massive evaporation. But human actions are absolutely accelerating the crisis. We're talking overgrazing, deforestation, and, most critically, the unscientific overexploitation of groundwater. Because of completely unregulated tube well pumping, over 70% of blocks in the state are now categorized as dark zones, which basically means the groundwater there is severely, dangerously overexploited.
Now, to fight back against this land degradation and something called the dreaded triacol, which is a really tough simultaneous scarcity of water, fodder, and food, communities and governments are actually implementing some pretty aggressive control measures. We see step-by-step mitigations like planting tree shelter belts to act as natural windbreaks against those creeping sand dunes, engineering massive surface water transfers like the Indira Gandhi Canal, and a big one, reviving hyperlocal, traditional water conservation structures.
Let's look a little closer at those traditional structures, actually, because they are absolute marvels of desert engineering. Take a tanka, for instance. It's an underground, circular cistern built directly into rural homes to catch literally every single drop of rainwater from the roof. Then you have a kadin, which is an earthen embankment, famously pioneered by the Paliwal Brahmins of Jaisalmer. It's designed to essentially catch surface runoff on flat farmlands. These are incredibly ingenious systems. They allow communities to capture and retain whatever scarce water they can for basic survival in agriculture, especially when surface rivers just don't exist.
All right, transitioning underground for Section 4, we discover that beneath all this dry, cracked, and thirsty soil lies an absolute treasure trove.
The source material repeatedly refers to the state with this very profound title, the Museum of Minerals. But why exactly does it carry that nickname? It's an interesting question.
Well, the answer is that the geological variety under the sand is just staggering. I mean, the state possesses reserves of over 81 different minerals. In fact, Rajasthan holds a near-total monopoly. We're talking 90 to 100% of India's entire national production in non-ferrous minerals, things like lead, zinc, and wollastonite. And this massive output is driven by colossal deposits, like the Rampura Augusha mine. Fun fact, that is actually the world's largest single underground zinc mine. Huge, right?
But hey, the wealth isn't just underground. Above ground, that harsh, relentless sun, the same one that causes so much evaporation, is now being harnessed as a primary, incredibly valuable resource. Rajasthan boasts over 325 sunny, crystal-clear days every single year. This immense amount of solar energy directly powers the Bodless Solar Park in Jodhpur, which, by the way, is currently the world's largest solar park. With a staggering estimated potential of 142 gigawatts of solar energy, this desert is super fast becoming the undisputed green energy powerhouse of India.
Okay, for our fifth and final section, Fruits of Labor, let's explore how people actually earn a living and, amazingly, cultivate prosperity in such a challenging environment.
Despite everything we've just learned about the erratic monsoons and those incredibly sandy soils, the agricultural output here is, quite frankly, mind-blowing. Did you know Rajasthan is actually India's leading producer of pearl millet, also known as bajra, as well as mustard and guar? It actually contributes over 80% of India's entire guar output. And in the places where crops might fail, livestock absolutely thrives. Sheep, goats, and cattle are actually revered as the Dhan, which literally translates to the wealth of the desert. They provide this essential year-round economic security and fuel a massively successful cooperative dairy industry. Now, this agricultural miracle is largely powered by massive infrastructure. This actually brings us right to a big question detailed in the source text: what exactly is the impact of the Indira Gandhi Canal Project, or IGNP? Well, the answer breaks it down beautifully. Engineered by a visionary named Kanwar Singh, the canal physically routes Himalayan water all the way from Punjab across hundreds of kilometers. Its socio-economic impact is nothing short of a revolution. It is quite literally turning sandy, barren wastelands into lush, fertile agricultural belts, all while supplying vital drinking water to 10 different desert districts. The source text sums this entire concept up with a really powerful quote. It says, "Irrigation has the same importance for agriculture as hydropower has for industries." That really hits the nail on the head, doesn't it? In a semi-arid region like this, controlled water application isn't just a helpful bonus. It is the absolute, non-negotiable engine of all productivity. Without it, the whole machinery of desert agriculture simply stalls out.
But as we wrap up this explainer, we really have to look to the future. With rapidly dropping water tables, highly fragmented land holdings, and a visibly shifting global climate, we have to leave you pondering one vital question. What new innovations and strategies are going to be required to keep this desert miracle thriving in the decades to come? It's a massive geographical puzzle, and it's going to take immense human ingenuity to solve it. Thanks so much for joining me on this explainer, and keep exploring.